We introduce OptiSense, a data-driven system for automatically finding the best places to put strain sensors for wearable motion tracking. Rather than using intuition based on anatomy to place sensors, we start by collecting simultaneous rotation angles of the joints using motion capture and skin strain data using a dense grid of optical markers on the shoulder joint. Then, we use a pathfinding algorithm to search for all valid sensor paths across the surface that match real-world sensor length and placement constraints. With this, we identified 86 unique candidate sensor configurations. These become the starting population for our genetic algorithm. Each configuration is evaluated using a random forest model trained on our recorded data. The model takes strain signals as input and predicts joint angles from our simultaneous strain and joint tracking, letting us measure how well each sensor setup performs with performance metrics, such as the root mean square error. Top-performing configurations are selected. We then apply crossover and random mutation to generate new combinations and explore better options. This process runs for 50 generations, steadily improving tracking performance with each step. In the end, we get an optimized 3-sensor layout that significantly outperforms traditional placements. Let's look at the difference, sensor by sensor. On the left is the reference setup placed over the deltoid muscle belly, a common choice based on anatomy. The optimized version shifts it closer to the center of the body, where the strain pattern is smoother and more consistent. Sensor 2 moves down from the upper shoulder to a lower area. This new location bends more smoothly and predictably during arm movement, capturing motion more clearly and avoiding skin or fabric folding near the neck. Sensor 3 rotates outward, away from the spine, and crosses diagonally across the back of the shoulder. This area shows high directional strain that typical placements miss, but it provides richer, more separable signals during complex arm motion. Finally, here's a motion tracking demo using both configurations. The reference setup struggles with reconstruction, especially when the arm is raised and slack appears in the strain sensors. In contrast, the optimized layout produces smoother, more stable motion that closely follows the ground truth. With 3 sensors placed on the shoulder joint and 1 on the elbow, OptiSense reduces tracking error by 47%, speeds up training, and delivers more accurate results, all through smarter sensor placement. This demonstrates how data-driven sensor positioning can dramatically improve tracking quality, highlighting that sensor placement is not just a setup detail, but a critical design decision that deserves careful exploration.